Now we have to discuss how to calculate correlation coefficient, and it is actually denoted by small r. Before explaining the calculation process of correlation coefficient, we have to know what is the definition of correlation coefficient, or what is it actually. Now we have to talk about correlation. If we have given two variate, one is x, another one is y. Now here we assume that x means English marks of 5 students and y means maths marks of 5 students. Now we want to compute the correlation or relationship between x and y. We have to check whether relationship exists or not, and it can be calculated by r, or something is called correlation coefficient. As we know, the relation or relationship between two things can be three types of. One is, it can be positive relationship, can be negative, or can be zero. Zero relationship means there is no relationship actually. If x increases, y also increases, then this is called positive relation. And similarly, if x decreases, y decreases, it is also called positive relationship. That means both are going to the same direction. If one increases, other also increases. In the second case, we can see if x increase or decrease, y still unchanged, that is, it is constant. We see there is no change in y. So it is called zero relationship in between x and y. And in the third case, we see if x increases, y decreases, or if x decreases, y increases. That means there is a negative relationship. So in first case, that is in case of positive relationship, we can see the upward rising curve in the first quadrant, that is in the quadrant of x and y. And in case of third one, that is in case of negative relationship, we can see the downward sloping line, that is the negative relationship in between x and y. To represent or show the second situation, we plot another diagram, and here we can see the line is parallel to the horizontal axis. It shows zero relationship in between x and y. That means whether x increase or decrease doesn't matter to y. It remains unchanged. Now again we are going back to correlation coefficient, that is small r. Here we have shown the formula for correlation coefficient. So the denominator is sigma x and sigma y. Sigma x means that is standard deviation of x, and sigma y means standard deviation of y. Here numerator is covariance of x and y. So we have to find covariance of x and y first, and then we have to calculate sigma x, that is standard deviation of x, and standard deviation of y. Here one thing should be mentioned, that is x and y values will be given. Now here we have taken an example. If x is given by 2, 3, 4, 5, 6 and y is given by 4, 2, 3, 6, 5. So from this given equations, given x and y series, we can easily calculate sigma x and sigma y, that is standard deviation of x and standard deviation of y. By using these two formula of standard deviation, that is for x and y, the calculation of standard deviation of x and y is very easy. Now we have to calculate covariance of x and y, and the formula is very easy, and here it is given sigma xy by n minus sigma x by n and sigma y by n. As we know, sigma x by n means the formula of mean, and sigma y by n means the formula of that is mean of y, or y bar. So covariance can be written as the value of x and y are given, so automatically we can calculate xy. Therefore xy equals to, xy means multiplication of x and y. So the first is 2 into 4, that is 8. 3 into 2, that means 6, and this way we are having the other values 12, 30, 30. Now we have to calculate sigma xy. Sigma xy means summation of xy. Here sigma xy equals to 86. And what is the value of small n? Here the value of small n is 5. That is, in case of x and y variate, we can see 5 numbers are given: 2, 3, 4, 5, 6. And in case of y, 4, 2, 3, 6, 5. That is 5 numbers are. So n equals to 5. Now we have to calculate x square and sigma x square, y square and sigma y square, which will help to calculate standard deviation of x and y. And similarly, we have to calculate sigma x, sigma y, which will help us to calculate covariance of xy as well as standard deviation, because both in covariance as well as in standard